Okay, the first thing we're going to do is get rid of these fractions. So the common denominator between 5 and 6 is 30. You don't have to look at the 3 because that's not a denominator. So we're going to take 30 and multiply by the first x over 5 minus the 30 multiplied by x over 6 equals 30 times 3. So we're multiplying 30 by each thing. And then we're going to cancel. 5 goes into 30 6 times, and when we multiply that, we get 6x. 6 goes into 35 times. When we multiply that, we get 5x, and 30 times 3 is 90. So x is equal to 90. Here, x is showing up in multiple terms, and these are not like terms, so they cannot be combined. So we have to isolate x by factoring it out. So I'll take out an x and open up a parentheses, and we'll have a minus de. And now I can solve for x by dividing each side by a minus de. And of course, over here they cancel. So we're left with x is equal to 5 over a minus de. For number 3, the first thing we're going to do is get rid of these parentheses. So I'm going to start by distributing the negative 3. We'll get negative 3x minus 12, and then we have the minus 1 equals 11. I'll combine like terms. Negative 12 minus 1 is negative 13. And then I'll bring the 11 to the other side by adding it. You can show it like this or just do this in your head. But you'll end up with negative 3x is equal to 11 plus 13 is 24. And then you'll divide each side by negative 3. And you'll get x is equal to negative 8. Okay, here's the term with the x. I want to isolate that by moving this to the other side. And remember, if you move a term to the other side, it simply switches signs. So that's a positive 2y over here. That's still a positive 4. And then we're going to solve for x by dividing each side by 5. So x is equal to 2y plus 4 over 5. Okay, x is showing up in two terms, but these are like terms. So we just combine them and get 8x. And now we divide by 8, and we're going to get x is equal to 4. There's just a single term on each side, so we'll solve by dividing each side by negative 3. We'll get x is equal to negative 7. Okay, we need to divide each side by negative 5, but remember, when you divide or multiply each side by a negative number, the inequality is going to flip direction, so it's going to go from a less than to a greater than. So if you thought about this on a number line, negative 7 goes like this, and it brackets like this. So in interval notation, we go from negative 7 up to infinity. This is our negative 7. This is our infinity. We're going to start by getting rid of that negative 5, so we add that to each side. I don't think you need to show this by now, but you have 2x is greater than or equal to 30. So now we'll divide by 2. And we'll get x is greater than or equal to 15. So if you think of this on the number line, it looks like this. So we have 15 to infinity. When you have these compound inequalities, you're just solving for this inside part. So to get rid of the 2, we move that to either side by adding 2 to each section. Negative 8 plus 2 is negative 6. 4 plus 2 is 6. So in interval notation, this goes from negative 6 to positive 6. And we're having parentheses, not brackets, because these are less thans, not equals. So those are parentheses. Okay, first we're going to graph each one. So on the number line, put your 3 down to the left of 7. Now greater than 7 looks like this. Less than greater than 3 looks like that. Less than 7 looks like this. The and is the intersecting portion, which is just, I didn't draw it very well, but it's that portion right in there only. So this is 3 to 7. So here we're going to solve each one. This one I'll divide by 3, and we're going to get x is greater than 6. Here I'm going to divide by 2, and we're going to have x is less than negative 4 divided by 2 is negative 2. So I'm going to draw a number line. I'll put negative 2 to the left of 6. Now, greater than 6 looks like this. Less than negative 2 looks like this. This upside down U means the intersection, the point that they share in common, but they don't share anything in common. So this is an empty set. Okay, I'm going to graph this. So I'll put 3 to the left of 10. Greater than 10 looks like this. Greater than 3 looks like this. The or means any portion of the graph covered by either one. So all of this stuff from 3 to infinity is our final solution. On this first one, we're going to divide each side by 5, and we're going to get x is greater than 30 divided by 5 is 6. On this next one, we're going to divide by negative 4. Remember, when you divide by a negative number, the inequality flips directions. Negative 40 divided by 4 is positive 10. So on the number line, I'm going to put 6 to the left of 10. And greater than 6 looks like this. Less than 10 looks like this. And because this is a union, that's the upside down U, it's the place covered by either line. So all the way from negative infinity up to positive infinity. Whenever you have an absolute value, first make sure this is positive, and it is. So you set this up twice. When it's a greater than, you set it up twice. So you're going to take it out of the absolute value and leave the inequality and the number after it alone, put a comma, take it out of the inequality, and flip this, you get out of the absolute value, and flip this and this. Then on the number line, you put down negative 7 to the left of positive 7. Greater than 7 looks like this. Less than negative 7 looks like this. So we have to include both of these. So this goes from negative infinity up to negative 7 with a bracket, union, and this right side goes from 7 to positive infinity. That's our 7 to positive infinity. So all of this is part of the answer. Remember, when you have absolute values that are greater than, you're going to have 2 intervals when you're done. When you have absolute values that are less than, you're going to have just 1 interval when you're done. Here we have an absolute value and it's equal to a positive number, so we'll set this up twice. We take it out of the absolute value and we leave the right side alone and go comma, take it out of the absolute value, equals, and flip the right side and solve them both. So I'll bring this over by adding it. 5 plus 3 is 8. Divide each side by 4 and get x is equal to 2. Move this over. Negative 5 plus 3 is negative 2. Divide each side by 4 and get x is equal to negative 2 over 4, which is negative 1/2. So our answer is negative 1/2 and 2. And you could have put that in either order. Just be careful. Do not put these in parentheses. If you do, you mean it's every number in between, but not including these. So these are done without any type of brackets. You could put these around them, but it's not necessary. For number 16, the first thing we want to do is isolate the absolute value. So we're going to start by moving the 7 over. And we'll get the absolute value of 3x minus 1 is greater than 2 minus 7 is negative 5. Well, an absolute value is always positive, or at least it's always 0. So it's always going to be bigger than a negative number. So we'll just stop right here, and this is all real numbers. Number 17, this is an absolute value which is less than a negative number, which means it's less than 0, and that's impossible. This can never happen no matter what x is. So this is an empty set. Here we have an absolute value that's less than a positive number. This is like the previous one we did. We're going to have one interval when we're done. So we'll just set this up twice using the sandwich method. So I'll go negative 2 less than 5x plus 1 less than 2. We're sandwiching this in between the negative and positive version of this. We want to solve for the middle. So the first thing we're going to do is get rid of the 1 by moving it to each side. Negative 2 minus 1 is negative 3. And 2 minus 1 is 1. And then we're going to divide by 5. So we get negative 3/5 less than x less than 1/5. So in interval notation, we write it like this. Negative 3/5 up to 1/5. Now, these need parentheses because there's no equal sign there. So it needs parentheses. If there's an equal sign there, we would have put brackets. Remember though, when you have an absolute value that's less than, you end up with one interval. When you have an absolute value that's greater than, you end up with 2 intervals with a union in between. Okay, first thing you want to do is make a number line and pop all those numbers in order down on it. So 1, 2, 3, 4, there's 4 numbers. 2 comes first, then 7, then 10, then 13. 7 to 13 with brackets looks like this. 2 to 10 with parentheses looks like this. This upside down U means the intersection, which is the point they share in common, just this part. So our answer in interval notation is a bracket on the 7, a parentheses on the 10. Because you have to look at what's being shown here. That's it. So for number 20, we'll make a number line, and we have 4 numbers, so I'll pop down 4 little marks, and then I'll put the numbers in order. Negative 5, 1, 8, 15. Okay. 8 to 15 with brackets looks like this. Negative 5 to 1 in parentheses looks like this. This is the intersection, the portion that they overlap or share in common, and there's nothing that overlaps. So this is an empty set. This time I have just 3 numbers. So when I draw my number line, I'm only going to pop down 3 numbers on it. And then I'll put them in order. So I go 2, 5, then 7. Okay. 2 to 7 with parentheses looks like this. Negative infinity up to positive 5 looks like this, with a bracket on the 5. This upside down, this U is a union, meaning the place that they share, that they overlap anywhere. So not just overlap, but anywhere covered by either graph. So all the way from negative infinity all the way up to 7. And I'm using a parentheses here because there's a parentheses there. Infinities always get parentheses. For number 22, there's only 2 numbers. So when I make my number line, I'll just pop down 2 spots. And I'll put 9 to the left of 12. Bracket 9 to positive infinity looks like this. Negative infinity up to positive 12 bracket looks like this. This means the union is something covered by either graph. So all the way from negative infinity all the way up to positive infinity. Okay, negative 2, negative 5 means 2 to the left and 5 down. So it's that point right there. And we'll call that A. And remember, well, let's do the next one. Positive 3, positive 2 means positive 3 in the X and 2 in the Y, which is the point right there, and that's B. Remember that the quadrants go like this. Quadrant 1 here, then 2, then 3, then 4. Like this. It starts with 1 in the top right and then goes counterclockwise. And they're always written in Roman numerals. You have to write them in the Roman numerals. So A is in quadrant 3. B is in quadrant 1. Okay, so number 27, we're graphing y is equal to 3x minus 4. So this is already in slope-intercept form. So this is our y-intercept. This is mx plus b. That's our b. So we go to negative 4 on the y-axis and draw a dot. And here's our slope, positive 3 over 1. So it's like this. It's like 3 over 1. So we're going to rise 3 and run 1. It brings us right here. And then we just grab our ruler. And draw a line through all of this. Put arrows on either side of the line. Don't forget your arrows. That's it. Number 28, we're going to graph 4x minus 2y is equal to 8. Okay, I'm going to use the intercept method. If we got rid of the y, 4x is 8, that tells us that x is 2. So on the x-axis at 2, I'll put a dot. Then if I got rid of the x, negative 2y is 8. So if I divide by negative 2, I get y is negative 4. So on the y-axis at negative 4, I put a dot. And then I just I put a line through these. And I put arrows on either side. That's it. For number 29, we're graphing y is equal to 3. So we go to the y-axis at 3 and put a dot. And this is a horizontal line through that dot. So there's our line. Put arrows on either side. For number 30, we're going to start with, we're graphing x equals negative 2. So we go to the x-axis at negative 2 and we put a dot. So this is a vertical line through that dot. And oops. And there's our answer. When you're finding the midpoint, the formula is the x value of the midpoint is x1 plus x2 over 2, and the y value of the midpoint is y1 plus y2 over 2. So for the x value of the midpoint, it's x1, 3 plus x2 is 7. For the y value of the midpoint, it's y1 plus y2, which is this plus this. Oops, what did I just do? 2 plus 6 over 2. So the midpoint that we're after is 5 for the x and 4 for the y. The slope formula is the rise, which is the change in the y values, over the run, which is the change in the x values. So y2 minus y1, 9 minus 5, over x2 minus x1, 8 over 3, which is 4 over 5. And that's it. All right, a graph that goes down from left to right has a negative slope. Oh. This is on the answer sheet, but you would circle negative. A graph that goes up from left to right has a positive slope. So again, this is on your answer sheet, but circle the correct word on the answer sheet. The graph of a horizontal line. A horizontal line is like this. We're rising 0 and running some. So that's a 0 over anything is 0. So that's a slope of 0. The slope of a vertical line, well, that's rising some and running 0. So it's some number divided by 0, which is undefined. So put this on your answer sheet, but it's undefined is a slope of a vertical line. Okay, we want the final answer in standard form, but we're going to start as a slope-intercept. So we'll start, I'm going to kind of write small because we have to write a lot. Y equals mx plus b. We're starting there. This is our y, this is our x, this is our m. We're solving for b. So we have y, which is 1, m, which is 2/3, x, which is 6, plus b. We're going to cancel here. 3 goes into 6 twice, and so we'll have 1 is equal to 2 times 2, which is 4, plus b. Bring this over here by subtracting. 1 minus 4 is negative 3. So b is equal to negative 3. then we're going to start with y equals mx plus b again. Now we have our m that was given, and we have our b. We just solved it. This is the answer in slope-intercept, but we want it in standard. So I'm first going to multiply everything by 3 to get rid of this fraction. So I'll get 3y is equal to 2x minus 9. That's multiplying everything by 3. Then I'm going to move this over to the left, and it's going to become negative. But in standard form, this cannot be negative, so I have to flip the sign of this, which means I flip the sign of everything. So the final answer in standard form is positive 2x minus 3y equals positive 9. For number 38, we're going to do something similar to this, but we have one more step, because we don't even have an m like they did over here, so we have to get the m. So our m is y2 minus y1 over x2 minus x1, which is 5 minus negative 4, that's a 5 plus a 4, over negative 4 minus 8, which is 9 over negative 12, which reduces to negative, let's see, dividing by 3, we get 3/4. So that's our m. Let's put a line between this so we can see what we're doing. Okay, then I'll do the next part, so I'll draw a little line there so I can separate this. I'm going to start with y equals mx plus b. Pick either point, it doesn't matter which one, so I'll pick this one. Here's our y value, here's our x value, and we have an m value that we just solved. So let's plug that all into this. Of y, which is 5, equals m, which is negative 3/4, times our x, which is negative 4, that's there, plus b. So this will cancel, and we're going to get 5 is equal to negative 3 times negative 1 is a positive 3 plus b. I'll bring this over by subtracting, and we'll get b is equal to 5 minus 3 is 2. Draw a little line to separate our work, and we're going to again start with the original y equals mx plus b. Now we solved our m, that was here, and we solved our b, that was there. So let's write that. Y equals negative 3/4 x plus 2. That's a positive 2. This is slope-intercept form, and we'd be done except that we need it in standard form. So I'm going to first get rid of the fractions by multiplying everything by 4. So I have 4y is equal to negative 3x plus 8. I have to move the x over, and I get a positive 3x plus 4y is equal to 8. And that's standard form, because in standard form, x and y have to be on the left-hand side, there can be no fractions, and this has to be positive. Number 39, a horizontal line is a line that looks like this, which is in the form of y equals, and they gave us a y value, so we're done. A vertical line looks like this, which is in the form x equals, and we have an x value, so we're done. Okay, for number 41, 42, we're graphing these two lines. So let's look at this one first. This has solved for y, so this is in slope-intercept form. When it's in slope, y equals mx plus b. This is our y-intercept at positive 5. On the y-axis, we'll make a dot. The number in front of the x is our slope, so a negative 1 is there. But as a fraction, that's negative 1 over 1. So we're going to go rise down 1 and run 1. And our next point is right there. When we graph this, we're going to be graphing a solid line because of the equal sign. So I'll grab my ruler and draw a solid line on this. And don't forget you need arrows on either side. Now, when we graph this, I'm not going to put this in slope-intercept form. The intercept method works better. So get rid of the y. If 4x is 8, then x is 2. So on the x-axis at 2, we'll put a dot. Now we go back and get rid of the x. We have negative 2y is 8, so y is negative 4. So on the y-axis at negative 4, we'll put a dot. We're just going to connect those. When I graph this, there's no equal sign, so this is going to be a dashed line. Oops. put arrows on either side. Now, when we go to shade, this is an and, so we're only doing the intersecting portion. This has been solved for y, and y goes up, down. This is a positive y, so we follow this. We're going to shade on the upper side of the solid line, this side. When we graph this, we can either look at the x's go left, right. If this is positive, you follow the arrow and you go to the right. So we're going to do on this side. If you did the y's go up, down, but instead of going up, because y is negative, you have to do the opposite and go down. So you can think of the right side of this line or the down side of this line as the same thing. So to this side of this line and this side of this line, the intersecting portion is right here. So that's what we're graphing. Just that portion in there. And that's it. Okay, the domain is a collection of the x values, so the -4, 3, and the -2, but we have to put that in order. So we open up a brace like that, and we go -4 first, then -2, and then 3. The range is the collection of y values, so we're looking at just the 8 and the 7. Don't write the 8 twice, but you do have to write them in order. In order to determine if this is function, look at just the x values. If they're all unique, don't worry about the y values, but just the x values. If they're all unique, then you do have a function. So this is, yes, it is a function. Okay, for the domain and range for this, we're looking at this. The collection of x values. The x values go back as far as -1, and they go to the right to infinity. So the domain is -1, including -1, because there's a filled-in circle there. So -1 to infinity. The range is how far up and down we go. We're going down as far as -3, and we're going up as high as infinity. So the range is -3 to infinity. Again, we need the bracket here because that's a filled-in circle, so we're trying to include that number, so we put the bracket. Is this a function? Well, visually you can see it's a function by using the vertical line test. There's no one single place where we could put a single vertical line that will intersect this in more than one spot, so this is a function. Our first function here is f of x is this. Our second function is g of x is this. F of 0 means we're replacing a 0 for there. That turns into a 0 plus 2, which is 2. G of 0 means we're plugging in a 0 here, which means we have a 0 minus 3, which is -3. F of -2 means we're taking it on the f function a -2 and plugging it there. So this is 4 times -2 plus 2, which turns into -6. G of -2 means we're taking a -2 and plugging it in there, but be careful, we have to write it like this, a -2 squared, then the -3, because we're squaring all of this and not just the 2 part. So when we square all of it, we get positive 4 minus 3, which is 1. Okay, for number 53, 54, we're solving these graphically. I'm going to put them down here, and we'll put our solution on the answer sheet. So this is easiest using the intercept method. If I cross out the y, we have 3x equals 6, so x is 2. So on the x-axis at 2, I'll put a dot. Then we go back and we cross out the x. We have -3y is 6, so on the y-axis at -2, we'll put a dot. So then I'm going to grab my ruler and draw this. Okay, now on this one, y equals 2x minus 5, this is in slope-intercept form. So this is my y-intercept, -5 on the y-axis, I'll put a dot. And my slope is 2, which as a fraction is 2 over 1. So I'm going to rise 2 and run 1. From this spot, I'm going to rise 2 and run 1. So I'll have a dot right here. What am I doing? That's not the starting point. My slope, my y-intercept was there. So I'm going to rise 2 and run 1. My dot will be there. Okay, now I'm going to graph this. And I'll put a arrow down on either side. And their point of intersection is right here, which is the point 3 in the x and 1 in the y. So as an ordered pair, we write it like this. And that's the solution for that one. Okay, here we're going to solve by substitution. Now, substitution is easiest when one of the variables has been solved for, and that's this case, so that's nice. So y is equal to this. We're going to take this and plug it in there. So we'll write 3x plus 2y, and y is this, 2x plus 9, is equal to 4. I just took this and stuck it in there in that equation. So now we'll distribute this and we'll get 3x plus 4x plus 18 equals 4. So 7x equals, I'll bring this over by subtracting. 4 minus 18 is negative 14. And I'll divide by 7 and I'll get x is equal to negative 2. Now you can put it anywhere you want, but it's always going to be easiest to solve for y here because it's already been solved. So we'll have y is equal to 2x plus 9. And x is negative 2. We just solved that. So here we'll get negative 4 plus 9, which is 5. So we write the solution as an ordered pair. The x comes first and then the y. And ordered pairs need parentheses. That's it. Okay, for this problem we're going to solve by elimination. So I can eliminate the x's by bringing them to 12, or I can eliminate the y's by bringing them to 20. I guess I'll get rid of the x's by bringing them to 12. So I'm going to multiply this by 3. I'll do it over here. I'll multiply by 3, and I'll get 12x minus 15y is equal to negative 90. And then I'm going to get, to bring this, I have to multiply not by 4, but by negative 4. And I'll get negative 12x, that'll give me an opposite, minus 16y is equal to negative 4 times negative 7 is a positive 28. And now I'm going to add these two together. My x's will go away. This will add up to negative 31y. And this will add up to negative 62. I'll divide each side by negative 31, and I'll get y is equal to positive 2. Then I can take that and plug it in anywhere I want. If I plug it in here, I'll have 4x minus 5y, and y is 2. That's going to be equal to negative 30. So 4x minus 10 equals negative 30. I'll bring this over. Negative 30 plus 10 is negative 20. Divide by 4 and get x is negative 5. So the solution is going to be, you always have to put the x first and then the y. So negative 5 and then 2. Okay, if you're going to solve this using a method of your choice, you could either solve for y here and use substitution and plug it in there, or you could use elimination. I'm going to use elimination. So I'm going to make this a negative 3 to get opposite to this. So I'm going to start by multiplying this by negative 3. And this times negative 3 is positive 9x. Then we have minus 3y is equal to negative 39. I'll leave this alone. And I'll add these together. 9 plus 2 is 11x. The y's add up to 0. And this adds up to negative 33. So when I divide by 11, I get x is equal to negative 3. Then I can plug that into either one of the originals. I'll plug it in right there. Negative 3x, and x is negative 3, plus y is equal to 13. So y is 13 minus 9, which is 4. So the solution is the x first and then the y. Okay, when you're dealing with negative exponents, whenever you see negative exponents, if you don't already have a fraction, make a fraction like this. And then move anything with a negative exponent to the other side of the fraction. So this will be 1 over 3 to the positive 3, which is 1 over 27. 3 times 3 times 3 is 27. Whenever you're multiplying, as long as the bases are the same, you add up the exponents. So we have x to the 5 minus 4 is 1, 1 plus 3 is 4. So this is x to the 4. And that's a positive exponent, so we can stop right there. Don't confuse negative numbers with negative exponents. This is just a negative 4. I'm multiplying it by 3, and I get negative 12. And then we have x to the 3 plus 2 is 5. And that's it. Whenever you're dividing, you subtract exponents as long as the bases are the same. So this is x to the 8 minus 4 is 4. So we end up with x to the 4. I'll multiply these first, then I'll worry about any negative exponents. So negative 5 times 2 is negative 10. And then I have x to the 3 minus 5 is negative 2. Now I'm going to create a fraction because I have a negative exponent, and I'll move this to the other side of the fraction, making it positive. So I'll end up with negative 10 over x to the positive 2. And you could have put this negative here or here. Either way is okay. For number 66, there's a lot going on here, but the first thing is that this is an even exponent, which is going to square away that negative, so that negative is going to become positive. And then I'm going to take that negative exponent and distribute on each one of these items. So I'm going to have a positive 3 to the negative 2, x to the positive 8, and y to the negative 10. I'm just multiplying this exponent. Times 1 is negative 2, times that is that, times that is that. Okay. Then, because I have negative exponents, I'll make a fraction bar, and this are going to go down. So I'm going to end up with x to the 8 over 3 to the 2, y to the 10. And finally, I'm going to simplify this because I can. You have to simplify everything you can. So you end up with x to the 8 over 9, y to the 10. Here I'm going to combine like terms. 4 plus 1 is 5. 5 minus 7 is negative 2. So we have negative 2x. Here I'm going to combine this and this because they're like terms. 4 plus 5 is 9. So we have 9x squared. And then I'm going to combine this and this because they're like terms. Negative 3 minus 1 is negative 4. These parentheses are redundant and can be removed. But then this negative is going to distribute, and it's going to give me a negative 3x plus 5. And then I'll combine like terms. This and this combine to 3x, and this give us plus 3. Okay, for number 70, these parentheses are redundant, so are these. You don't have to write it again, but you could. Just taking them out of the parentheses like this, and then you combine this and this to get 9x, and this, 2 minus 8 is negative 6. We're going to FOIL this. Our first is x times x. This outer is negative 3 times x. The inner is negative 4 times x. And the last is negative 4 times negative 3. These combine, and you get that. You can use the formula here. The formula is the first item squared, twice the product of those two. So the product of those two is 5x, twice that is 10x, and then the last item squared. If you forgot the formula, just write it out twice and FOIL it. And then FOIL that, and you'll get to that in the end. I'm going to FOIL this. The first is 2x times 5x. The outer is 2x times 2. The inner is negative 1 times 5x, and the last is negative 1 times 2. These are like terms, and they combine to negative 1x, but don't write the 1, minus 2. You can multiply these in any order, but I'm going to multiply these first, leaving the 3 alone. So I'll FOIL what I have here. So I have 3 times now. The first is 2x squared. The outer is a positive 3x. The inner is a negative 8x. and the last is negative 12. So I just combine these to get negative 5. Then I'll distribute in this, and I'll get 6x squared minus 15x minus 36. Okay, I'm going to start with the x, and I'll ignore everything else, and I'll distribute that. When I multiply by this, I get x cubed. When I multiply by this, I get a positive 3x squared. When I multiply by this, I get a negative 5x. Then I'm done with the x, and I move on to the negative 4, and I distribute that in. When I multiply by this, I get a negative 4x squared. When I multiply by this, we get negative 12x. And when we multiply negative 4 by that, we get positive 20. Then I'll add these up, and we'll get x cubed minus 1x squared, but don't write the 1, minus 17x plus 20. Okay, for number 76, 77, there's a mistake on the test. This should say more. Okay, so Mr. Ishii can bike 5 miles per hour more than three times as fast as he can run. So I'm going to say rate times time equals distance. And this problem, we're dealing with Mr. Ishii running and biking. All right, now it says that I can bike 5 miles per hour more than 3 times as fast as I can run. So I'll say x for run. 5 miles per hour more is that than 3 times as fast. So this represents 3 times as fast, and this represents 5 miles more than that. The time says I run for 3 hours, and I bike for 2 hours. So this will be 3x and 2 times 3x plus 5. Let me make that nicer. Okay. Now, it says that he's going to travel a total of 64 miles. So the total distance, this column added up, is going to be 64. 3x plus 2 times 3x plus 5 equals 64. I'll distribute this. So I combine like terms, and I get 9x. I'll move the 10 over by subtracting it. 64 minus 10 is 54. And then I'll divide each side by 9 to get x is equal to 6. That tells me how fast he's running. But if you want to know how fast he's biking, we go 3x plus 5. 3 times 6 is 18, plus 5 is 23. So Mr. Ishii can bike 23 miles per hour. And that's it. All right, number 78, 79. A rectangle that's 5 feet less than twice its width. So let's draw the rectangle. We don't know the width, so I'll put x. But 5 feet less than twice the width. And the perimeter is 38. So if I take 2 of the sides and add them up, that's half of the perimeter. I've only gone halfway around. So to get the other 2 sides, I can multiply this by 2, and now that's 38. I think the easiest way to do this is to divide each side by 2 to get 19, and then combine those like terms. So I did 2 steps in one. So I combined these like terms, and then I divided each side by 2. And now I'm going to add 5 to each side. So 3x is equal to 19 plus 5 is 24. So x is equal to 8. That means that 2x minus 5 is equal to 16 minus 5, which is 11. And they want to know the length. So the length is 11, and this is inches.